Hello everyone. I hope yesterday you had a pretty good understanding for unit circle. So yesterday when we talk about unit circle, we do mention there are some angles. We are going to discuss more about that. So today we are going to explore more about if I give you some special angles, then how do we figure out the coordinates of the angles when we draw on the unit circle. So let's have a quickly review. So yesterday we mentioned for unit circle, the center is on the origin and also radius is 1. And any random point here, we know x squared plus y squared equal to 1 because this is actually that's the equation for the unit circle. And we mentioned there are some angles here we can actually figure out the coordinates, and there are the one we mentioned here. For example, this one can consider as a 0 degree, and this one is 90, 180. Oh, sorry. This one is 270. Of course, when we come back here, 0 degree and the 360 degree, they have exactly the same coordinate. And also, if you go clockwise, then you will see this is actually same as negative 90 degree, just because they have same terminal ray. So that's why we call their coterminal angle. Coterminal angle have a same terminal ray. That's why they have exactly same coordinates. Again, you may wonder, why do we need to know the coordinates? Soon, when we start introduce a trigonometric function, you will understand where is that definition coming from and why we use that. Okay. So, since we keep saying special angles, then beside these angles here, what are the angles we are going to introduce? So today, I'm gonna show you actually very I wouldn't say famous, but every single time when we talk about unit circle, you will see this picture. So this one, the first time you see this is, wow, it's like, wow, are we going to actually talk so many angles? Not exactly. We are going to focus on these three angles here. As you can see, 30 degree, 45 degree, 60 degree. They are the special angles we are going to discuss. And the reason we mention that, because according to special features here, we do we can figure out the coordinates for this one. But for the other points, for the other angles, we don't discuss more. And also for these points, for these angles here, we can use the points to figure out the value for the trigonometric function. So that's why we are going to introduce this one. And we can use this angle to figure out why and how we figure out the coordinates. Okay, so let's start it. But before that, I want to have a very quick review. So there are certain things as a, very special foundation here we need to understand. So before we work on the special angle 30 degree, one thing I want to, let's draw here. So first thing we mentioned before, so in a regular, in any random right triangle here, we know the three sides, they follow Pythagorean theorem, right? So that's the first thing as a foundation for the 30 degrees here. And another thing I want to mention is, if in a right triangle here, if I know this is 30 degree here, then the opposite side of 30 degree is always half of hypotenuse. What does that mean? So that means this side, let's say, if this is, let's say this one is 3, then this will be 6. So this side, let me use a different color. This side is always half of the hypotenuse. That's two things we need to have as a foundation to understand the 30 degree here. So let's quickly check here. How do we figure out the answer? The first, we consider this unit circle. So we know center is on 0, 0. and also the radius is 1. So that's how we set up the foundation here. And also for 30 degree, meaning we have initial ray here, and we draw a 30 degree here. So this is 30 degree, right? So the question for us is, if I say this is x and y, a random point, x coordinate, y coordinate, the purpose for this one is, what is x, what is y? How do we figure out? So the first thing is, as you can see, we draw this, so I'm going to draw the little dashed line here. With this dashed line, we already have what? This is a right triangle, right? And this distance, the blue trace part, so the length of this part we know is actually x, right? And also the length of the vertical part here, let's use something different. This is what is y. This is exactly how do we mention the coordinate, because when we read the coordinates, the x, the directions is x and this is y. And we also know this is radius. This is radius, so this is y. Okay, so we know that x squared plus y squared equal to 1. Make sense so far? And also there's one thing, as I mentioned. We mentioned if this is 30 degree here, then the vertical distance here, the opposite side, is half of the hypotenuse, which that means if hypotenuse is 1, then y is half of this is this. So this is based on the future of the 30 degree. So now in order to find the x, I'm going to plug into the original equation here. So it's going to be x squared plus half squared equal to 1. So I'm going to figure out this one. So this one, I'm not going to use calculator, because the answer we do need to use exactly the value instead of using rounded decimal here. So let's solve this one quickly. So half a square, which is half times half, which is 1/4. So in order to do this, we are going to subtract this one so we can isolate. So 1 minus this, so again, this is actually everything is going to be based on the mental math, so it's going to be 4/4 minus 1/4, so it's going to be 3/4. Be patient here, we're almost there. So it's going to be 3/4. So in order to find x, I'm going to take out square root here. And since you're on the first quadrant, so x is positive, so I don't need to worry about this. Negative side, so it's going to be square root of 3/4. And also when we find the square root of fraction, we can take the numerator and break down as denominator, so the answer is this. So that means for 30 degree, the coordinate is radical 3/2 and y is 1/2. Okay, so that's how do we find this one. So the next, I'm going to put this coordinate here. So this is 3/2 and 1/2. Okay, now, so it seems that next we are going to focus on 45 degree, but we are going to skip this one. We're going to come back this later because I'm going to focus on the 60 degree here. You may wonder why, soon you'll understand this. So for 60 degree, as we mentioned here, this is the initial ray, and we just draw the 60 degree. So this is 60 degree. So if we draw very similar, the purpose for this one is, again, if I call this x and y, then what is x, what is y? I'm going to draw a, again, right triangle here. So let's quickly check. So this distance is x, right? And The vertical one is y. And we already know that according to the relation of this one, x squared plus y squared, of course, is equal to 1. But the question is, what are the values? So the reason why we have to mention 30 degree and then 60 degree, because if this is 60 degree, then we know this is going to be a 30 degree. So I'm going to draw the very big one here. So we know this is 90 degree, then 60 degree, so this is going to be 30 degree, just because all three angles add up to 180, so you can easily find this is 30 degree. So since it's 30 degree, then we mentioned before, no matter how do you draw the 30 degree, like the one we just mentioned here, 30 degree, the opposite side is always half of hypotenuse. So same thing here. So this is going to be half of hypotenuse, so this side. So in this case, meaning x will be half of hypotenuse, meaning half of radius, which is 1. Okay? See? So x is that. Then we just need to figure out the y. So if you really go back to check here, it seems that once the value one of the coordinate value is 1/2, the other one is radical 3/2. So that means for 60 degree, the only difference is we don't need to solve that. We know the y have to radical 3/2 because the solution, we already finished the solution here. So x, y only change the position. That means for 60 degree, we don't need to do more calculation. We know this is this. So I'm going to go very back here. So I'm going to write down this one is 1/2 3/2. See, they just changed the x, y coordinate. We switched it, and we can get 30 degree and 60 degree. Okay, so that's it. So now let's go back to the very last one, 45 degree. Okay, so 45 degree is initial ray here and exactly in the middle, because 45 is exactly half. So this is 45 degree. Again, I'm going to draw the right triangle here and x and y. And based on the one we mentioned before, this distance is x and this distance is y, and we know that x squared plus y squared equal to 1 because this is a right triangle and they follow Pythagorean theorem. Before that, I want to mention one thing. For a right triangle, and then this 45 degree, meaning the other side is also 45 degree, because all three angles add up to 180 degrees, so we can figure out they are both 45 degree. That means if I know this is, let's say this is like 3, and this must be 3, just because there's two sides are same because they have same angles here. We call this isosceles triangle. So that's a basic thing we need to know. So for this case, meaning we know x equal to y for this case because this is 45 degree. So we can just easily write down as, because they are the same, so I just replace at the same variables here, we can figure out. Then we can combine the like terms here, divided by 2 in order for x, and x squared is going to be 1/2. Okay, so x squared is going to be 1/2. Then in order to find the x, we have to find the square root of that. So you may wonder, okay, so this is going to be radical 1 over radical 2. So the answer is that. That's right. However, there's one thing I want to remind you. In math, when we simplify the fraction, we don't put a radical sign, square root sign for the denominator. We need to rationalize that. In order to do that, I just multiply the bottom with radical 2, top with radical 2. So this one will be simplified. Radical 2 times radical 2 is going to be square root of 4. 1 times this, always same as that. So the square root of 4, which is 2. So x is square root 2 over 2. That means y will be the same thing because we know x equal to y for this case. So that's why the coordinate is this. Okay, I'm going to go back very, very beginning here to write down that. Okay, now we have 30 degree, 60 degree, 45 degrees. So that will be the foundation for the first quadrant. Later we're going to, you may wonder, are we really going to figure out every single piece here? No, we don't. Next, I'm going to quickly show you what happened to these angles here. We will see that in the second video, okay? Hopefully this video is helpful. Again, any questions, you're always welcome to contact me. See you soon.